So we're doing the application of this. We're multiplying, we're using our distributive property with multiplying powers. And then we're going to end up at the end combining like terms. So if I have 4n gets distributed to all three terms, 4n times 3n squared makes 12n to the third. 4n times 1n is plus 4n squared. 4n times negative 4 is negative 16n. I'm going to distribute again. Negative 1n times 3 is negative 3n. And negative 1n times negative 1n is positive n squared, or 1n squared. Now that we've done that, we go through and combine like terms and write it in standard form. Largest exponent, 12n to the third, positive 4n squared plus 1n makes positive 5n squared, and negative 16n minus 3n is negative 19n. So we're just taking the skill, upping the level a little bit, distributive property with multiplying powers and combining like terms. Number 2, 4b times 5b minus 3 minus 2, parentheses, b squared minus 7b minus 4. So you go through, get that distributive property going. You have to distribute twice in this problem. And then once you've distributed twice, you'll go through and collect your like terms. (4b times 5b is 20b squared. Multiply the coefficients, add the exponents. If you need to put in those ones to remind you, do it. 4b times negative 3 is negative 12b. Moving on to the second part to distribute, negative 2 times b squared is negative 2b squared. Negative 2 times negative 7b is positive 14b. And negative 2 times negative 4 is positive 8. Combine like terms. 20b squared minus 2b is 18b squared. Minus 2b squared. I dropped the squared when I said it out loud. Then I have negative 12b plus 14b is positive 2b plus 8. Problem 3. I'm actually going to start down here because it's rather long. It's not huge, but it's just a little bit longer. So, 2 times 4k squared minus 2k minus 3 times negative 6k squared plus 4 plus 2k times k minus 1. So each time it's a monomial times a binomial, but we have it 3 times. Yes, Xavier? All right, someone out there who can tell me What is this first answer to the distributive property? Who can tell me? When you distribute that first monomial, it's really a constant, 2, into that binomial, what do you get? Anybody?
8k squared minus 4k.
Perfect. 2 times 4k squared is 8k squared. 2 times negative 2k minus 4k. Perfect. Now we're going to distribute again. Who can tell me this one? Distribute that negative 3 into that binomial.
Plus 18k squared minus 12.
Fantastic. Good. Negative 3 times negative 16k squared is positive 18k squared. Negative 3 times 4 is minus 12. Excellent. All right, we're distributing now a 2k to the last binomial. What do you get when you distribute that negative 2k? Or no, positive 2k. Go for it, Sarah.
2k, or it's positive 2k squared.
Yep, so plus 2k squared, perfect.
And divided, well, I meant negative 2k.
You got it, minus 2k, because 2k times negative 1 is minus or negative 2k. Perfect. Now we combine our like terms. 8k squared plus 18k squared plus 2k squared gives us 28k squared. Negative 4k minus 2k is negative 6k minus 12. Excellent, excellent, excellent. That was a big one, but we still got through it. It's the distributive property. If you take it step by step, we can tackle it. All right, so I want you to try number 4. I'll write it down. So you try out number 4. We've got a monomial times a binomial and a constant, a monomial, times a trinomial. And then after you distribute, put it all together. Combine like terms. Test it out. See how you're doing. Distribute first. Use the properties of powers. Multiplying powers. And then combine like terms. So we have m times 3m gives me 3m squared. M times positive 6 is plus 6m. Negative 3 times m squared is negative 3m squared. Negative 3 times 4m is negative 12m. And negative 3 times 1 is negative 3. Combine like terms. 3m squared minus 3m squared cancels out. 6m minus 12m is negative 6m minus 3. Give me a reaction. How did that go? Thumbs up. I'm feeling good. I can do it. Thumbs down. I definitely need more practice. It looks pretty good if I was going to judge that. Okay. Now, let's take it up a step. Why not? Here is my picture. Oh, I gotta get. So we are going to find the area of the shaded region. So there's a little bit we need to talk about. Area of a rectangle is base times height. Correct? Bottom times how tall it is. And if I want the shaded region only, what's the process that I need to do? What am I going to have to do to figure out just the shaded region? Because there's a region that's not shaded. What am I going to have to do? How can I solve this problem? Let's talk through the process. Any ideas of what we need to do? You can type it in the chat. You can say it outside or out loud. Crazy talk, I know. Good, Bryson. Good, Seth. Isabella, what do you think we have to do?
Find the area of both of the rectangles and then subtract
Perfect.
the larger one minus the smaller one.
Excellent, excellent, excellent. So we have to find the area of the first rectangle and then the area of the second rectangle. So the largest rectangle is base times height. So I'm going to do height is 6x times the base, 8x minus 1. Could you flip these around and do 8x minus 1 times 6x? Yeah, you just distribute from the back half instead of from the front half. Doesn't matter. So my large rectangle is 6x times 8x is 48x squared. And 6x times negative 1 is negative 6x. That's the big rectangle. Now I find the area of the smaller rectangle. Again, base times height. So 2x times 5x plus 3. 2x times 5x is 10x squared. And 2x times 3 is positive 6x. After you found the large rectangle and the smaller rectangle, we subtract. So I'll come over here. Large rectangle minus small rectangle. So 48x squared minus 6x, that's the large rectangle. That belongs together. It's going in parentheses. It doesn't mean multiply. It's just telling me that that represents a relationship. Minus 10x squared plus 6x. It has to go in parentheses when you're subtracting that entire binomial. Because think back to what we did with addition and subtraction in our notes. You couldn't just put a minus sign in between it and not have those parentheses because the minus belongs to both of those terms. That's why those parentheses were there. I have to take that -1 and subtract both terms in that binomial. So 48x squared minus 6x minus 10x squared minus 6x. You have to subtract the entire binomial, and since they belong together, you have to distribute that minus to the terms, not just the leading coefficient. 48x squared minus 10x squared is 38x squared. Negative 6x minus 6x is negative 12x. All right, I'm going to show you this one. Try it out. It's the same process. It's a rectangle within a rectangle. We're finding the shaded region. It's a little bit different. Obviously, it's different in the fact that there are different numbers. There's a little twist or a little change up, maybe less work with that inside rectangle. But you try it out yourself. Try it out. Try to find the answer. Same process. You're finding the large area, the area of the large rectangle. You're finding the area of the smaller rectangle. And then you're subtracting. But remember, when you subtract, you're subtracting that term or that polynomial or that monomial or that whatever. It belongs together. So the large rectangle is 4x times 3x plus 2. 4x times 3x is 12x squared. And 4x times 2 is positive 8x. That's the area of the large rectangle. Did we get that? Thumbs up? Area of the smaller rectangle, in this instance, it's just a binomial times a, or not binomial, a monomial times a monomial. It's just one term times one term. 3x times 2x is 6x squared. I don't have a binomial or a trinomial or something. I just have a monomial for the area of my smaller rectangle. Now I can take my larger rectangle, 12x squared plus 8, and I can subtract the area of my smaller rectangle, which is 6x squared. I don't really need to distribute because it's just, it's only a monomial. But if it was a binomial or trinomial or polynomial, I'd have to distribute to everything inside. In this example, it is just 12x squared plus 8x minus 6x squared. Like terms, 12x squared minus 6x squared is 6x squared plus 8x. In the chat, will you please give me a ranking, blank out of 10? How do you feel about monomials times a polynomial and combining like terms? These skills. How do you feel? What's your personal feeling? If you were going to give yourself a check for understanding, this is how I feel. Some of you guys in your decimals cracks me up.